In this video, I plan to review the M7 Inequalities Test Review Qualifier that you all had. It might look familiar as I start to scroll down, and it was, let's see how many total questions. It was 15 total questions. This was the very last question. And I'm going to go through this now so that you can have reviewed before you try to retake, okay? So for number 1 on the qualifier, again, this was the qualifier Google form that you guys had to complete for homework. And for number 1, you're just translating. And when we read from left to right, we have 8 less than a number is at least 10. So I have is at least 10, so I've circled it away, which means all of this highlighted stuff has to be at least 10. If it's at least 10, it could be 10 or more. So all of this highlighted stuff can be more than or equal to the 10. Now let's translate with this than. When we scan for than and we box it, a number goes first. Now show me 8 less than that. So 8 less than a number is at least 10, has now been successfully translated, and it would have been this last answer choice right here. Just so y'all know, at least and at most are always going to have the or equal to line up underneath it. All right, now for number 2. When we are solving, when we drop that line, we're going to identify that the constant is a positive 2. So we're going to subtract 2 from both sides so that it cancels out. Over here, same sign, add and keep. Now we're left with a negative 6 as our coefficient of b, and it's greater than or equal to the negative 36. Now when we divide both sides by this coefficient, the negative 6 cancels out because negative divided by negative is a positive 1. So b is by itself. Over here, this negative divided by negative is a positive 6, and we will flip the symbol because we divided by this negative number right here. Because we have a negative coefficient, we are dividing both sides by a negative, and that is why we flip the symbol. And over here, we're going to select this second answer choice. Now, this one and this one could immediately be knocked out because they don't even have the or equal to line up underneath it. And the first 2, you could actually knock out the first answer choice because you can see right here that if the variable is on this side and we're having a negative coefficient, we will need to flip. So this one doesn't flip the symbol. So you could actually get this correct answer using process of elimination. Speaking of process of elimination, right here for number 3, when we're trying to translate, I can't get into your head to see what your eyes see first when you look at a problem, but I can clearly see that over here we're going to have a greater than 20, and I see right here less than, which is why I'm able to knock out the first answer choice. As I just mentioned with at least and at most, it could also include the number. So at least 20 could also include the 20. And since our problem doesn't have that or equal to line, I've also knocked out this answer choice. Now the 2 remaining answer choices both have the than when we scan. So for this one, 4 less than, the quotient of a number and 3 should come first. So the quotient of a number and 3 comes first. Now show me 4 less than that. Is greater than 20 would be is greater than 20. And it looks like right there we've successfully translated, and this would be our answer right here. Now I would like to point out that for the last one, where it says the quotient of 3 and a number, that would have 3 in the numerator and then x would be in the denominator because 3 goes first. And so then for more, actually this has a plus, so that'd be for more, and then it would be greater than 20. So that's what answer choice D translates to, just so you know. Obviously the first one, some of you might have knocked this first one out because it said 4 more, which would be addition. So some of you might have immediately realized it has to be one of these 2. The correct answer for this third one was this second answer choice right here. Okay? Now moving on, still just translating. Again, we're just working on the qualifier, trying to review before you retake. So for this one, twice the number is definitely what we're looking for with the times 2. A number squared, just so you guys know, would have an exponent, so it can't be either one of these 2. Nope, nope. All right? Now let's figure out right here, twice the number plus 5, twice the number added by 5. So far, both of these are still fair game. Now let's figure out if it's at least or at most. So I like to highlight and talk about the stuff. So this highlighted stuff has to be more than or equal to the 14. If it's more than or equal to the 15, it's at least 14. So more than or equal to is at least. We have a greater than or equal to, and it should be at least. So the first answer choice here correctly translates. Now for the next one, where we have this x minus 8 all over 3 is greater than the negative 1. All you really need to do for this true or false question, if it's asking if 5 is a value that will work, we're just going to plug in the 5 right there. So 5 minus 8 is negative 3. Negative 3 divided by 3 is negative 1. Now we've got to figure out, is negative 1 bigger than negative 1? No, this is a false statement. For this to be a true statement, we would have needed the or equal to line underneath it. Now this was kind of easy because all you had to do was plug in the 5 right here and then simplify and then check to see. I would like to take the time real quick to review the difference in these two types of problems. If you look carefully, I think you could agree that in both of these we have a denominator of 3, and in both of these we have a constant of negative 8. The question is, where is the constant? So I'm going to start over here where the constant is its own separate term versus when it is a term up here with the numerator. So over here, when it's its own separate term, the first thing you're going to do is just do the opposite. If we have minus 8, we're going to add 8 to both sides for this to cancel out. Now the constant is 0, and we have x divided by 3 left over. On this side, negative 1 plus 8 is positive 7. Now to get rid of the denominator, we're going to multiply both sides by 3, and it's going to cancel out over here. We did not multiply or divide by a negative, so I'm not flipping the symbol. And 7 times 3 is 21. So x has to be greater than the 21. Now over here on this side, since the constant is part of the numerator, first we have to get rid of this denominator. And when we multiply both sides by 3, now the denominator is gone, and this numerator is all by itself. Just like we did over here, we multiplied to get rid of a denominator, and the numerator is all by itself. Except this time, the numerator isn't still alone. It actually has a negative 8 with this x. So now is when we're going to get rid of the 8, and it's going to cancel out over here, and x will be bigger than 5. So it's all about wherever the constant is. If the constant is its own separate term like you're used to seeing, you're going to get rid of it first. However, if the constant has become a part of the numerator, you're actually going to have to wait until after you get rid of the denominator to now get rid of this numerator. Okay? Now I want to go back and continue looking at the test review that you guys had. For number 6, to ride the Ferris wheel at a carnival, your weight on the car of the Ferris wheel must be at least 100 pounds. So if you're looking at the 100 pounds and this is how much you weigh, you have to weigh more than 100 pounds in the cart to be able to ride. It also says at least, which means you could weigh 100 pounds and still be able to ride on the ride. So what we've got then in the problem is that Jenny and Michael want to ride this together. Now Jenny already weighs 70 pounds. Now we got to figure out how much Michael could weigh, and eventually when we subtract the 70, we'll see that eventually Michael just needs to weigh more than 30 pounds, and together they could ride the Ferris wheel. Now the question just asked which inequality would be used, so their weight over here has to be more than or equal to the 100, and so that's going to be this last answer choice right here. All right, we have another translating question for number 7. I'm just going to read through the first one, And we're just going to read through each of these and find out which one shows 4x minus 5 is greater than the negative 21. The product of 4 and a number decreased by 5. So I don't have any thans there, y'all. So we can translate from left to right. The product of 4 and a number, it's about to get decreased by 5. Then it says is greater than negative 21. And what do you know? We're already at our answer choice. Now the next one, I can knock it out because it says greater than or equal to. So see you later. Some of you might have just immediately knocked that out. Some of you see 4 times the difference. And you're like, oh man, anytime we had a difference, it was 4 times. And then we had to put the difference in parentheses. So some of you might have saw 4 times the difference and immediately knocked that out. And for the last one, the difference of 4 and a number multiplied by 5 is greater than negative 21, has the 4 and the 5 and it has it flip-flop from what we want. So the correct answer here was the first one. The product of 4 and x is 4 and x, 4x, decreased by 5, minus 5, is greater than the negative 21. All right, for this one, I'm going to recommend that you actually just take the time to solve it. If it was only one of these numbers, you can just plug it in. Like up here, if it just asks for one value, just plug that one value in. But down here, since it's asking for 2 of them, let's go ahead and solve. So when we solve 6b minus 3 is less than or equal to negative 15, we're going to add 3 on both sides to cancel out the constant. Then, because we have a coefficient of 6, we divide both sides by 6. It wasn't a negative number, so I do not flip the symbol. And a negative 12 divided by 6 here would be a negative 2. Now we want values that are less than or equal to negative 2. This and this, both negative 2 and negative 3, are smaller than or equal to negative 2. So this one would be true. All right. Moving right along now to question number 9. For question 9, when you solve this inequality, you subtract 8 on both sides. And we get 12 minus 8 is 4. Now when we divide both sides by the negative 2, I will flip the symbol. And we're looking for x is less than negative 2. So we have a circle on negative 2, and it's going to be open. So bye-bye C, bye-bye D. And some of you would have even caught that since we have to flip the symbol, we have to shade less than. So some of you might have been able to get this answer choice B without even necessarily needing to solve, because A would show greater than, and we know we need to flip the symbol. So this one is B. For number 10, if the student council needs to raise at least $300 for the school dance, and they're going to be charging $5 per ticket, these $5 per ticket, we want to raise more than or equal to $300. That's going to be this last answer choice. So for at least, friendly reminder, we have a greater than or equal to. All right, now for number 11, I'm showing here we have the 2 methods. Because it's just one number, I'm going to recommend that we just plug it in. So if we take the 8 and plug it in right here for x, a negative 1/4 of 8 is negative 2. You can do 8 divided by 4 is 2, times 1 is still 2. And since it's a negative times a positive, it's a negative 2. Now when you add 2 to that, you're going to get 0. And now you just got to ask yourself, is 0 smaller than negative 3? No, it is not. So this would be a false statement. Sure, you can solve it. You can drop your line and start to solve. But that's just going to take more time. I think for this one, it's easier to just plug it in. All right, so now we're on question 12, and for this one, my recommendation is going to be when you see this fraction to just go ahead and make it a decimal. And now the problem becomes negative 2.5x is greater than or equal to negative 15.5. Our coefficient is this negative 2.5, so we're going to divide both sides by that. And because it happens to be a negative that we divide on both sides, we will be needing to flip our symbol around. And the negative 15.5 divided by a negative 2.5 in the calculator is a 6.2. So this is going to be x is less than or equal to 6.2. Now for number 13, Mrs. Kim has at most $22.50 to spend at the carnival. At most. She bought a hot dog and a drink for a total of $375. She wants to spend the rest of the money on ride tickets, which cost $1.25 each. Which one of these inequalities shows the number of ride tickets that she can buy? So the $375 that she spent on the hot dog and drink plus the $1.25 per ticket has to be less than or equal to the amount of money that she can spend. So when you see at most, you need a less than or equal to symbol. And then when you come over here to match, that is going to be the second one. 3.75 plus $1.25 per ticket has to be less than or equal to the $22.50 she has to spend. All right, for this next one, 4/5 is not a coefficient, so we do not multiply by the reciprocal. 4/5 here is a constant, so I have just made it the 0.8, and now we're going to subtract 0.8 on both sides and cancel it out. X will be over here, and 10 minus 0.8 would be 9.2. So we want anything that is less than the 9.2. Over here, the question asks, which values below make the inequality true? So we don't want to pick 9.2 because it's not or equal to. We will pick 9 because it is less than, and we will pick 7 because it is less than. And I think we have one more question left, and here it is, question 15. So for question 15, you have your 3/4 x minus 1.5 is greater than 10.5. So when you drop the line, you're going to identify the constant as negative 1.5, and we add 1.5 on both sides. That's going to cancel out, and this time our fraction is a coefficient, so we will need the reciprocal. 10.5 plus 1.5 is 12.0. So now over here, we're going to multiply both sides by the reciprocal to make the coefficient a 1. Now that the coefficient is a 1, x is all by itself, and over here we're going to do times 4/3. So 12 divided by 3 is 4, times 4 would be 16. It was not a negative, so I do not flip the symbol. So x has to be greater than 16, which is this one. So this problem was a two-step inequality because it had a constant and a coefficient for us to get rid of. That takes care of the entire video of your qualifier. Thank you.